Okay, before we really get into all the tools, what I want to impress on you is the importance of understanding what digital files are. Okay, now an STL file is essentially a big long list of triangle coordinates. Okay, and I'll show you some visuals to help hit that home, but what that essentially means is the more triangles you have, the larger the file size is going to be, and I'll explain that further. But the big takeaway from this brief discussion is that these digital files are just triangles, a lot of triangles. And so when you're in MeshMixer and you're trying to decide how you want to manipulate these triangles, thinking of them as triangles and not like a stone model is helpful, because it helps you to wrap your mind around what tool do I need to use to do this, or if this tool is failing, why? Why is it struggling to get past this step that to you might seem like it's an easy step, and why is the software so dumb and it can't do it? But if you step back and you think of it like a triangle, you will realize that it's pretty straightforward. Okay, so I'm just going to go through this quick presentation that I made a while back. I edited some things for this course, but I just want to kind of hit some ideas home. So in dentistry, a lot of people know the term digital dentistry, and if you ask a lot of dentists, do you do digital dentistry? They say, oh yeah, I do digital dentistry. I'm digital in my office. Normally that means digital health record, digital x-rays, and at the most they mean that they are also doing intraoral scanning so that they can mill a crown, something like CEREC. It's been around for a long time and a lot of dentists have adopted this technology. But that's not what I mean by digital dentistry. Obviously that is digital, but I always think, boy, it's a big leap forward from that. It means that we are doing digital wax-ups, okay? We're doing digital dentures, surgical guides, CAD/CAM surgical guides, but then also digital hybrids, milling out bars, individual teeth on those. It's much more than just crowns. And so, you know, CEREC is a great system, but to me it's very limiting, okay? And it's very expensive for how limiting it is, because for the same cost of what somebody might pour into a CEREC style unit, you can get a bunch of open source systems and be able to do almost anything under the sun, which is what we do in our office. So what makes up these digital objects? It all comes down to coordinates. Like I said earlier, everything in an STL file is a coordinate. It's a little dot that is there to hold information of space, okay? Then you connect those into lines, and then you fill those in, and then you have faces. And so how is it that you get all these little triangles to become an object? Hopefully you already have that concept down, but think of it this way. If you have a graph and you've got these XYZ coordinates where you plot A, B, and C, you can connect these together and create a face. So that's one triangle, but that's still two-dimensional. Where things become three-dimensional is when you add in a third coordinate, a Z coordinate. So having three coordinates, you can position one vertices in three-dimensional space, okay? And if you get a whole lot of those, you can start, well, this is just, you know, three coordinates, but showing it in a three-dimensional space. But if you get a whole lot of those triangles and you start zooming out, you can see that one triangle can make up quite a bit. And so this concept of dots and lines and faces is exactly what we're using in dentistry, as we use an intraoral scanner or a desktop scanner or even a cone beam CT scan. As we're using this information to gather what these 3D objects are, it starts off as just a bunch of dots that are then connected into very small triangles, and then those are the faces that make up our models. So the question then becomes, and this, I alluded to this earlier, I said that the more triangles you have, the larger the file size, which can become problematic. So you got to be careful. I'll introduce a tool that's common out there in MeshMixer, and that's Make Solid. A lot of people use the Make Solid tool because to them it seems to be a solution to something they might not otherwise know the answer to. And so, it's a great tool when used properly, but it gets overused. And the reason I say it gets overused is because if you want to use the Make Solid tool and maintain your accuracy, you have to really crank up the resolution, meaning those triangles get very, very small, just so the software is able to replicate the detail that you originally had. And even then, you're changing it. And so, and the file sizes get massive. I mean, I'm talking massive, like 90 plus megabytes, which in the digital space, in the CAM side, that's a problem. Like a 3D printer and the milling software, it struggles to handle those large file sizes. All right, so how many faces do you need? I really like this image. I found this a long time ago, and it's in a lot of my presentations on digital dentistry when talking about resolution. Because if you think about this, each of those three images there is a sphere. But as you can see, when you have fewer triangles, you can't replicate the shape quite as well as when you start adding more and more triangles. Now, obviously, there becomes a point where adding smaller triangles or a larger number of triangles just doesn't help you out at all. You know, it just cranks the file size up, but it's not going to mill it any better or print it any better. Obviously, these ones are some extremes, and I'll show you some dental extremes. This is a wax up that was done for a patient years ago, and so you can see there's 5 different STL files here. There's the model, and then in the patient's missing their 4 anterior teeth, so these are teeth waxed into there. And what I did, and you're seeing this in reverse, but I took the original wax up and then I just started reducing the number of triangles so you can kind of see where the progression lies. So, you know, I start adding, remember this is in reverse, so we start adding back more and more triangles, and you can start to see, and the difference between the top and the bottom is only that the bottom one has the wireframe turned on so you can see the triangles, okay? And as it goes forward, you can see why I did that. But right about here, you start to, like anybody might start to recognize that, oh, hey, these are teeth, okay? And right there, it's undeniable that they're teeth, but yet it's still useless for anything that you want to do. Right about here is where it starts being useful for maybe just some diagnostic steps, okay? But really, you know, right about there is where I would say most dentistry is happening when it comes to diagnostic setups, when it comes to surgical guides, things like that. This is enough resolution. But if you start getting into things that require a high level of resolution or something that requires certain things to be high resolution, like a crown margin, you need even more resolution. And you can see the difference here between the top and the bottom. These are the same STL file, but you turn on these triangles and you can start to appreciate how small those triangles are getting. And then you take it one step further and you look, that is a very clear, beautiful scan, okay? But you look down here and you think, boy, that's a lot of triangles. So the question is, you know, how many is necessary? Well, it depends on what you're doing. It really depends on what kind of resolution you're after. And this is, I'm not going to dive deep into it because some of that's a personal decision. This is just me saying certain things are more important. So a crown margin and making sure that the crown you make is going to fit and be sealed is very important. It's going to require a higher resolution. Models, then dentures, then diagnostics. So, you know, dentures sit on movable soft tissues. It can tolerate having less resolution and still have success. And the thing you always have to kind of take a step back at is to try to realize that CAM can only do so much. And so if you're going to mill or print something, the resolution of the printing and the milling is limited. And so even if you have, you know, let me go back. Even if you have a model like this, it doesn't mean that this model is going to print differently than this model. You know, the difference between these two models, I mean, look at the bottom one. Oops. Look at the bottom one. You can see a difference in those triangles. But look at the top one as I toggle between the two. Barely a difference. And I go back a little further. Difference between these two when it comes to printing, it's probably not going to change at all. So you got to think about, what am I going to be doing with this STL file? All right, so it depends on what you're doing. Why not just use high resolution or tiny triangles for everything? Why not just make all of them look like this? Well, it's as I've been saying this whole time, it's all about file size, okay? If you look right here, this is a case I did where I had to wax up the mandibular 6 anterior teeth, and I just took the original and made it less and less and less. And obviously down here at the bottom, that might not be as desirable for certain things, but it certainly could be a model that you could make a matrix on and use that to make some provisionals. But if you look at the number of triangles and the file size, that file size dropped by 36, okay? It started off as 36 megabytes and went all the way down to 1.1 megabytes. Now, where's ideal? I would say ideal is probably this one right here, okay? I would say this would be my goal, is to shoot for something around here. I don't know what the hard limit on a printer is. I do remember a long time ago I took a really high resolution model into Blue Sky Ortho and did some minor changes. I was going to do some ortho on a patient, and the model came in high resolution, so everything coming out of it was high resolution. And I was trying to print numerous models to be able to print, and I could only get maybe 4 or 5 models, not because of the size of the build plate. There was more room. It was after I reached about 4 to 5 models, the software started to just almost grind to a halt. An example in the milling, the first time I ever tried doing a hybrid in Mesh Mixer, which I don't necessarily recommend, but I did a hybrid frame, individual crowns, individual preps with individual crowns that would go on those preps, designed completely in Mesh Mixer, but because of all the tools that I used along the way, the file size shot up to about 90 megabytes. I mean, twice what you're seeing there, almost 3 times what you're seeing there. And the Hyperdent, the software that runs the mill, it wouldn't even open the file. It was too large to open, and that was in the beginning before I had much experience with Hyperdent. Now I know that Hyperdent is going to struggle with anything over around like 8 to 9 megabytes. Well, 8 to 9 megabytes is far from here. It's anything from here and below. And so you have to watch those things. If you're using something like ExoCAD, 3Shape, chances are it's going to export out at a lower resolution. But if you're using Mesh Mixer, it's not paying attention to those. You have to pay attention to it. So looking at triangles is important. But again, like I said, the takeaway from this brief discussion is the importance of seeing these things as triangles. And I hope throughout the course I can remember to keep pushing that concept. And as I'm showing you different tools, talking about how they're triangles and what the tool is doing to each of the triangles. And so I just thought it was interesting, and did some math and divided it out. And it turns out that you get about 500 kilobytes, or about half of a megabyte, for every 10,000 triangles. So if you're ever just kind of curious, you know, what you're shooting for, and I'll go back. I told you before that I thought this looked like a really ideal place to be, and it's right around 4.6. So I would say, you know, if you can shoot for something around 100,000 triangles, you're going to be in a good place. If it's double that, you're still fine, but you're starting to hit a limit. And so anywhere between like 1 and 200,000 triangles is going to be your goal for a full arch restoration. So I hope that helps, and I hope that knowing these things and really thinking about them now helps as your progression through Mesh Mixer.